Good evening, everyone. Thank you for coming. I hope you've had a chance to get a snack. At the end, by all means, feel free to grab any of these stickers, flyers, and so forth. But today I'm really excited. We do have a wonderful presentation, as you probably would have seen on social media and the Astronomy Club newsletter that went out. So today we have Joe Bruce, who's a fellow NASA Solar System Ambassador from Spokane, Washington. He received a BA in Education with a focus on science from Central Washington University. He is involved in community service in Spokane. He's an educator, lecturer, and artist who offers programs in Washington, Idaho, and most recently, Guatemala. Joe has visited several NASA centers around the country and been present for 4 Space Shuttle launches. That's really impressive. Some of his artwork has been flown to the International Space Station. Joe visited Space Shuttle Endeavour when it was under construction. He toured the vehicle assembly building at Kennedy Space Center, and on 2 occasions he was able to volunteer at Explore JPL. So without further ado, Joe,
I'll stop your slides.
Welcome to the East Brunswick Astronomy Club meeting for July. Thank you for making the time.
Thank you. It's great to see you all there. And hopefully it's a little cooler in New Jersey than it is here in Spokane. We're enjoying a nice toasty 95 degrees today. I saw on the web where you may have had maybe 85, so I'm envious of you. As Isaac said, I am a solar system ambassador, and there's about 1,300 of us scattered throughout the country. And I get to serve in Eastern Washington, Northern Idaho, and get a chance to go in and talk with lots of kids. As an ambassador, for me, that's a lot of fun. So what I want to do today is I just want to walk you through some space history from the early days of the space program into the present and maybe into the future a little bit. And on the table in front of me, it's a little hard to see from where you are. I have some artifacts from the space program. Some of them have flown. Some of them have helped us get into space. But the first thing I want to do, the screen behind me, I'll try and enlarge as much as I can so that you can see it. I want to give you a little bit of a sense of what it's like to live on board the International Space Station for 6 months. So this will be about a short 4-minute video that I'll talk you through. There's the International Space Station, and when we were flying shuttle, we would be right now about 600 feet below the station, and we would be docking right there at that port. And so here's the Space Shuttle, again about 600 feet below the station. The cool thing about it is station shuttle at this point are traveling at about 17,500 miles an hour, or 5 miles a second. We'll talk a little bit more about that in a few minutes. But you'll notice in a few seconds, the shuttle's going to start doing something. It's going to start doing what's called an RPM, a rendezvous pitch maneuver. And we did that in the days of the shuttle so that we could get a look at the bottom of the shuttle and take lots of photos of it. You can see it's pitching over now because the shuttle was covered with thousands of heat-resistant tile. And those had to be in good shape before it came back to Earth through the fiery reentry on its way back home. So now they're taking thousands of pictures of the shuttle just to get an idea how it's looking, and then they'll send those photos back to the engineers on Earth. Fun thing here, they're traveling upside down and backwards at 5 miles a second. I don't know about you, but that gives me a little woozy. Here in a second, we're going to go on board station, and you're going to see one of the Russian cosmonauts exercising. We have to exercise about 2 hours every day to maintain our health, but in space, everything floats. So notice that right in front of the face of the cosmonaut, there's something floating. Watch what happens when he taps it. Everything floats. And there you can see it just floating away. Here we're bringing cargo up. That's probably clothing and food for the astronauts. And that's probably a bag of water. That was a byproduct of power systems on board shuttle. And that's Marcia. Bye, Marcia. Everything floats. When you're on board station for 6 months, you still have to do all those hygiene things. And any of you kids there in the audience tonight, you still have to brush your teeth, you still have to take a bath, but there are no showers. You get to wipe yourself down with a wet cloth. Here, Commander Sergey's getting a drink of water. Now that looks like a lot of fun, but everything floats. Keep watching here. They're floating right here and here. There's big gulp and gulp. I've always thought it would be so much fun just to float outside the space or in the shuttle, or station, and just float there. But you'd probably be waking up in the morning pulled into some sort of air conditioning duct. So what the astronauts do is they zip themselves into a sleeping bag and attach themselves to a wall. No pillows are required. Swimming in space, you don't even need water. Here's swimming through the Russian segment. Susan is just bringing in some new equipment. Here on Earth, I wouldn't be able to move that equipment. It's so heavy. But in space, she just floats it in, and she'll drop it into this hole in the floor or ceiling. Everybody likes to have dinner together as often as they can. You'll notice here they're using pita bread for sandwiches. Pita bread doesn't crumble and get into the equipment like sliced bread. So actual flying saucers, I don't know. You'll notice they're tossing candies at each other. Oh, that looked like that hurt. But what better way to get your candy than having somebody toss it at? I always have kids ask me, are there aliens in space? And I'll tell them, yes, they're inflatable. So that's just a brief introduction on what it's like living on board the space station for 6 months. Now, these are original 7 astronauts. I call them race car drivers because in the early 1960s, we were in a race. So when I ask students in school, I'll ask them, where are we racing to? And they will tell me we're racing to the moon. I'll ask them, who are we racing against? The Soviet Union. So the thing there is, in the early 1960s, the Russians had already launched the first satellite in space. They launched the first animals in space, the first humans in space, and our rockets at this point were getting off the pad, and many of them exploding. So these guys were pretty brave to know that they were going to get on top of a big explosive, and it might go off. So we were at that point in the early 1960s, we were behind in the space race. That's Al Shepard's flight. Al Shepard was the first American to fly in space, 15 minutes up in space and then back into the Atlantic Ocean. Several years ago, I was down at the control room where this launch took place, and I'm in visualizing where you're seated now. That control room was about half the size of the room you're in now, and the walls were lined with cupboards. So if you take out your cell phone, I'm going to step up front a little bit here. If you take out your cell phone has more power than that entire room did in the 1960s. Does anybody still use thumb drives on your computer? I still do once in a while. Well, that's a thumb drive from the 1960s. I picked this a roll of tape, digital tape, and I think it's 7-channel, and it ran at several feet per second, but it ran on their equipment, and that's how they collected their data and stored it. I don't know if the equipment, I can't even find the equipment to run this anymore to see if there's anything on that tape. So there's your thumb drive from the 1960s. So hang on to that cell phone you've got because you can do a whole lot more with it than we could back then. All right, I'm going to enlarge this a little bit. There's Earth, and there's our moon, 240,000 miles away. In order for us to go into orbit and circle our planet, we have to be traveling 17,500 miles an hour. That's 5 miles a second. Remember I said I'm a teacher? There will be a test, I promise you. So remember one of those two numbers, 17,500 miles an hour or 5 miles a second, because it will come back in our discussions in a few minutes. So in order to go around our planet, that's how fast you're going to have to be traveling. Now, I talk to folks here in Spokane, and I tell them, and you can do that there in East Brunswick too. Think of something that's about 30 miles away. And if you're in East Brunswick right now and the space station passes overhead, what I'll have you think about is just a few seconds. Think about how fast you're traveling at 5 miles a second. All right, go. Oh, wait a minute. You're now 30 miles away. Here in Spokane, I would have just traveled from Spokane to Coeur d'Alene. That's 30 miles away. In 6 seconds, you'll travel 30 miles. Imagine hopping on a school bus and traveling at 5 miles a second. The astronauts, they will see 16 sunrises and 16 sunsets in a day traveling at 5 miles a second. They'll go around the planet in 90 minutes. So that gives you a little bit of a sense of what 5 miles a second, how fast it is. So wherever East Brunswick is in relation, how about New York City? Is New York about 30 miles away?
More.
A little more? Okay. So anyway, that at least gives you a little bit of an idea of how fast you're traveling. The fun thing about this picture, I'll show this to little kids. I'll ask them, who is that? And just about every one of them can tell me John Kennedy. In this picture, John Kennedy, this is September 12th, 1962. John Kennedy at this speech, he's at Rice University in Texas, he's making a speech. He's setting a goal for the United States to send people to the moon and back in less than 8 years. No big deal, right? Except the materials to build a rocket didn't exist when he made that speech. The tools, the procedures didn't exist when he made that speech. Matter of fact, I think if I'm remembering correctly, we had maybe roughly 3 hours of flight time under our belt when he made that speech. And remember the Russians, they were still pushing and ahead of us in this race to the moon. It was a big deal. Whoever in the 1960s could get to the moon first and return. This is the Titan rocket, and with the Gemini spacecraft on board, and there are 2 astronauts that will fly in that. And oftentimes they would send them up for a 2-week mission. Any of you kids ready to fly a 2-week mission in that? If you think of a Volkswagen Bug, that's how much space they would have to live in for 2 weeks, 2 people. Now, there's some interesting things that happen to our bodies when we go into space and in a microgravity environment. One of the first things that happens is, where you are right now, gravity is pulling you down to the floor, and it's pulling the blood in your body down to your feet, and your heart's having to pump it back up through your body and circulate it. Well, in space, those astronauts, that's not the case. The blood, it actually pools in their face. Many of the astronauts are almost unrecognizable because their faces get real chubby because the blood is pooling in their head. The next term I use is an official medical term. They get the chicken leg. Their legs get real skinny because, again, the blood is pooling more in their head. So the astronauts, they're sitting there in their spacecraft for 2 weeks. Their muscles aren't being stressed, their bones aren't being stressed, and their body's saying, I don't need this calcium in my body. So your body starts getting rid of the calcium in your bones. And if you're up there for, say, 6 months, you'll lose somewhere around 10 to 15% of your bone and muscle mass if you're in space for that long without exercise. That's not a good thing to happen if we're going to it takes 2-year round trip mission to Mars. That's not a good thing to happen. One of my favorite things to talk about, though, is in flying in space, is if I'm standing here in my museum in my home and I look off to the left and then I turn my head and look to the right toward the spacesuit, my eyes send a signal to my brain saying, Joe, you're moving your head from left to right. In our inner ears, there's some little hairs with crystals on called otoliths. When we turn our head from left to right in gravity, they send a signal to our brain saying, Joe, you're turning your head from left to right. My brain's happy. It's getting the same signal. For those folks on board that rocket, that spacecraft, when they turn their head from left to right, their eyes send a signal to their brain saying, you're moving your head left to right. But their inner ear, being in microgravity, it sends a different signal. Many of the astronauts, the first 24 hours, they're sick because their brain is confused and they're not feeling great. When I'm going to hold this up a little closer so you can see. What's really fun is when I talk to a group of kids, I'll have 2 students come up and help me with this. And I'll do the same little presentation I just did for you. I'll hand this to them. And we'll talk about food. If they're going to be in space for 2 weeks, they're going to have to eat food. Well, here on Earth, we eat our food, our bodies process it through, we know what happens. We have to get rid of it. Well, it's about that time that the students that are holding this bag realize what they have in their hand. This is a space potty. And so all of a sudden, they're about ready to drop it out of their hand. And I'll tell them, no, it's okay, it hasn't been used. But they too, the astronauts, they are going to have to get rid of the waste. And so what they'll do is tape one of these onto their bottom, do their job, and then they store it away. Because in the early days of the space program, we didn't know if our eyes were going to distort so that we couldn't see our control panel. We didn't know if we were going to be able to swallow. We just didn't know. So the doctors here on Earth wanted all of this and urine samples back so that they could tell what's happening with our bodies when we flew in space. So today on the board of the space station, they have a much more modern restroom than that. Here gives you a sense. That's the astronauts in their Volkswagen Bug, where they're going to live for 2 weeks. Any of you students in the class or in the room now, you ready to go fly for 2 weeks? Let me see any hands that are ready to go fly for 2 weeks in space. Oh, I see some there. Okay. So I didn't scare everybody off from a flight. Okay. This is dead white. Now, the Russians, they beat us in spacewalk. Alexei Leonov had already walked in space. And so this is the first American to walk in space, dead white. And on his suit, if you see here, you can see where the sun is hitting his suit. The temperature is hot enough you could fry an egg, almost like that. But here in the shade of his suit, the temperature is cold enough you can freeze ice cream almost instantly. So there's almost about a 500 degree or so temperature differential just within inches of each other. So the astronaut suit, it protects them against extreme temperatures one way or the other, but it's also their small spacecraft. It provides air for them to breathe. I'm going to bring this a little closer so you can see. This is a space shuttle glove, and you'll notice it's white. The white, so that it's reflective. That white, if you're standing outside on a hot day and you're wearing a dark shirt, I see some of you with dark sweaters on or dark shirts on, you're going to be a little warmer than somebody wearing a white suit like this. The white acts like a mirror and reflects it. So this would have been used later in the shuttle program. In the later days, they put heaters in the fingertip because in the early days of the shuttle program, when they're in the shade of the shuttle or behind the Earth in the shadows, the temperature would drop so much that they'd almost get frostbite in their fingertips. So these had heaters in there so that they didn't get frostbite on their fingers. So that's just a more modern shuttle glove. Now we're working toward moving into newer gloves to take us on to the moon and out into deeper space to Mars. All right. That picture, and it's a little hard to see, I think, from where you are, but there's a 363-foot tall rocket there. It's a Saturn V. Built up over 7 million pounds of thrust. This was in December 1968. There were 3 people on board that rocket, and they were headed to the moon. They weren't going to land in 1968. They were going to look for possible landing sites. Now, in that time, it took about 3 days to get to the moon, and then 3 days to get back. So again, they had to take a lot of food with them. This pouch, here, tilt it so I don't get a reflection off of it. This pouch is some of the food that went on that flight. This was a day 7 meal. They had leftover food with them. I call it beef something or other. The folks that I got this from couldn't tell me what's in it. The reason I call it beef something or other is because it looks like there's some brown flecks in there. And what they would do is they'd pump hot water in, squish and squeeze until it was like toothpaste, cut the top of the bag off, and squeeze, and that was our hamburger for the evening. There were chocolate cubes in there for dessert. So anybody ready for a hamburger a la bag version? After 1968, I'm not so sure I want to try it. But this is what they saw Christmas Eve when they got to the moon. 240,000 miles away. Everybody they knew, every person that had ever been born was back there, had been on that little blue ball. They could take their thumb and they could hold their thumb up and cover up that planet. Those folks came back changed. They saw how fragile that little blue ball is floating in space. So that gave us a different perspective. That photograph actually is quite famous because it was the first photograph that gave us a sense of where we are in this universe. So just a little bit different perspective. All right, kids, here's a test for you. This is our solar system. Well, I've been talking distances, 240,000 miles. This is hard for me to visualize. Well, here's another number. There's Earth, there's the sun, 93 million miles away. That too is hard for me to visualize. So what I'm going to do is I'm going to put all you folks in East Brunswick, I'm going to put you in that Volkswagen Bug, and you're going to be driving 60 miles an hour, nonstop, 7 days a week, 365 days a year. How long, and tell me in years, because I don't have my calculator on me, how many years do you think it would take us to drive 93 million miles at 60 miles an hour? Any guesses there in the room? You may have to repeat them to me so I can hear them, but.
How many years?
Yeah, how many years would it take?
500.
A little less than 500. Good guess, though.
Good guess. Any other guesses? 809, is that close?
I'll give you a little bit of a hint. It's less than 200 and more than 50. We'll take a couple more guesses, and then I'll let you know.
100?
A little higher.
175.
175.
I heard somebody really close. Very good. It would take 177 years to drive 93 million miles at 60 miles an hour. Your grandchildren are going to probably drop you off somewhere around Venus. SPF 495 sunscreen. That just gives you a little bit of a sense how big this little solar system that we live in. That's just Earth to the sun. Out here is Jupiter. So where we live is an expansive place, and we just live on that little blue dot. All right, we just had an anniversary. This is July 16th, 1969. There are 3 people on board this spacecraft, and they're headed to the moon, and they're going to land. So, who was the first person to walk on the moon?
Shout him out.
Armstrong.
Very good, Neil Armstrong. Now, I have a ton of fun when I'm in a classroom embarrassing teachers. So I may do this for you adults. Kids, don't say anything. Adults, I'm going to see if I can embarrass you as well as I do teachers. Who was the second person to walk on the moon?
Buzz Aldrin.
Oh, very good. The reason I do this, it was Buzz Aldrin, and we did beat the Russians to the moon. But the reason I do this exercise is because in 1969, when this was going on, there was a lot of things going on in our world. The Vietnam War was happening. There was a lot of social unrest on our campuses and in our country. And so a lot of people, they saw the moon landing, and then they went on to other things. There were other things happening around them to take their attention. As a matter of fact, by the time we got to Apollo 15, 16, and 17, there wasn't even a live TV coverage of landing on another body in our solar system. A lot of people can't even tell me how many people actually walked on the moon. And there were 12 people that actually went to the lunar surface and walked on the moon. So just a little bit of an idea of what was going on at the time and why we don't remember some of the history. So there is Neil Armstrong on the surface. There's only 2 pictures I know of Neil. Here, he's at the base of the lander. Another one is a reflection of him off of Buzz Aldrin's face mask. He had the camera most of the time, so there aren't many pictures of Neil. The vehicle that they were in was so fragile that if I had it here in my basement or there in East Brunswick, it wouldn't even be able to support itself. Matter of fact, let's see, Grumman is not too, if I'm not mistaken, I may be off by a long shot with my geography, but Grumman was on the East Coast, not too far, maybe, that built the lunar lander. So you can correct me on that if I'm off, but I think we're not too far from Grumman where it was. But that vehicle was so fragile, I've heard rumors you could stick a screwdriver through the sidewall of it. It was so fragile. And there's Buzz coming down the ladder. And again, Neil taking pictures. Anybody ever watch Apollo 13? Raise your hand if you watch Apollo 13. See a few of you. Apollo 13, great movie, lots of suspense, even though we knew what was going to happen. No language. It was just a good, suspenseful movie. Well, on the way out to the moon, they were about 200,000 miles away from the moon, and they'd just done a TV telecast back to Earth, and they were getting ready for bed. The last thing that they were supposed to do was to stir some tanks behind them in the service module. What they didn't know was there was a short, and when they did that, it ignited one of the tanks, and the oxygen that they needed to continue the trip out to the moon and back home the 3 days vented out into space. So what they had to do is they had to shut down the command module real quick, transfer the information out of the computers down to the lunar lander, and move down into the lunar lander, which is designed to take care of 2 people for a short stay on the moon, not 3 people for the rest of the trip out to the moon and 3 days back. Now, you see here a picture. They have lithium hydroxide filters, air filters on the vehicle. Where you're seated now, you breathe in air, you breathe out carbon dioxide. Not a problem, because the library where you're at, they've got air filtration system, doors opening, closing, so there's no problem. But in that little spacecraft, that was a problem, and the carbon dioxide would build up and eventually kill them. So they had round filters that would filter out the carbon dioxide and keep them alive. The unfortunate thing is, with 3 people, they went through the round ones pretty quick. So they had to move back up into the command module and bring down the square ones, and square ones don't fit in round holes for some reason. And so they had to modify those with bungee cords, plastic bags, and vacuum tubes. Well, what I have here is a lithium hydroxide canister. This is one of the rectangular ones. It wasn't flown, it was left over from the program. But if you look on the side, you'll see a signature on there. That is a Buzz Aldrin signature. I handed this to Buzz several years ago, and he said, "What's that, a battery?" I thought, this is cool. I get to tell Buzz what that was, what some of the equipment was. So Buzz and I had this conversation. I told him there was a lithium hydroxide canister, and he did sign it for me, even though I told him what his equipment was. It's been a lot of years, so I'll give him credit. And here's a picture of Buzz signing my canister for me. Any golfers in the room? Anybody like golf? Okay. Well, this is Al Shepard. Remember, the first American to fly in space? Al Shepard was an avid golfer, and so much so that in the pouches on his suit, he took some golf balls and the head of a golf club. When he got on the surface, he dropped one of the balls on the surface, and these suits, in a vacuum, they're very stiff. So he couldn't get a good two-handed swing, so he had to swing with one hand. So there's video of this. He swings, big, beautiful plume of dust, and he looks down, and the ball's still there. So he swings again. This time he connected. Now, Al claimed that the ball went miles and miles and miles and miles. And you'll hear that in the video if you'll watch it. Well, the ball didn't go quite that far. In the last few years, there's been some digital remastering of those photos, and they found some of the balls about 40 yards out. I'm saying he at least got a hole in one because there's a crater out there with a golf ball in it. So at least probably got a hole in one. There's John Young. He's about 2 feet off the surface of the moon, saluting the flag. And here's a picture taken from this area over here. There's a car, and it's real hard. Again, I apologize for the size of the slide, but there's a car right there. There are 3 of those cars still on the moon, but it was taking a picture back of him, and then Charlie Duke is taking this picture looking that way. So we took 3 cars out there so that we could get farther away from our landing sites and pick up more samples. And I like telling the kids when I talk to them, you can drive one of those cars if you get up there, but you've got to take a fresh battery and you've got to have a lunar driver's license. Where they're getting a lunar driver's license, I don't know. It makes a good story anyway. This was 1972. This is the last time we had folks on the moon. They're taking off. There's 2 people here in the lunar lander with the ascent module taking off. They're headed back up to meet with Ron Evans that's been waiting for them. Harrison Schmitt was the geologist. He was the only geologist flown to the moon. And so I love telling kids, if you go back to the moon, folks, bring me back some rock samples. I'd love to have a big rock in my display. So 1972, that was the last time that we went to the moon, sent people to the moon. Fun thing is, we're working right now on the Artemis program, where we're going to be sending people, hopefully next year, out to fly on a 10-day mission, fly out around the moon, kind of like Apollo 8 did, and then fly back to Earth. And then a few years after that, hopefully we're going to land people back on the lunar surface. Apollo 18, Apollo 19 were canceled. Interest went away, funding went away. And so if you want to see some of the equipment that would have flown us to the moon on those missions, go down to Houston or Kennedy Space Center in Florida, and you'll see some actual equipment that would have flown us on those later missions. So we beat the Russians to the moon. Then we flew Skylab, huge space station. We sent 3 crews up there. The longest crew was up for 84 days. And to give you an idea how big it is, that kind of a sense of how big it is. But the thing about this is it shows you how strong astronauts are. He's holding him up with one finger. No, he's not. Remember I said everything floats? Well, he's floating at the tip of his finger. So anyway, we sent the 3 crews up. The last crew was up for 84 days. We brought them back, and we were hoping to be able to get the Space Shuttle flying in time to boost the space station into a higher orbit. Unfortunately, shuttle wasn't available and wasn't ready in time. So in 1979, the Earth's atmosphere was heating up because of solar activity, kind of like what's happening now with the sun and our atmosphere. And Skylab came back to Earth and burned up in Earth's atmosphere. Why did Skylab burn up? Why did it burn up on reentry? Any ideas?
No guesses?
No guesses? Take your hands and put your hands together like this. And rub as hard as fast as you can. What happened?
Friction.
Friction gets hot.
Yes.
So there was a lot of friction. Why was there so much friction generated?
Speed.
Speed? Did I hear speed?
Pressure.
I heard somebody said speed, I think. So what was the speed?
5 miles per second?
I told you there was going to be a test. Imagine plunging your hand into Earth's atmosphere at 5 miles a second. There's going to be a lot of heat generated. And that's what happened with the Skylab. There was a lot of heat generated. The vehicle couldn't take the pressure, and it began to tumble and break up. Also, as it came in, the air in front of it couldn't get out of the way fast enough. And so the air was being compressed. And we know that as we compress a gas, it gets hotter. So everything around Skylab was getting hotter. It couldn't take it, and it began to break up. And some of those tables in front of you, those were chunks as big as those, came and landed on Australia. In 1979, we weren't real friendly, or the Australians weren't real happy with us dropping big chunks of Skylab on them. So that was kind of what happened to Skylab, and we do have some of those chunks now on display around the world that people can see, but that's how we end up with things coming back where they shouldn't be sometimes. And space debris is a real problem that we're having to look at right now. We're getting so many things up there and orbiting our planet, and sometimes they come back and sometimes chunks survive. So we have to look at that. So after Skylab, we flew shuttle, and this is the launch I took my 2 kids to, and my daughter was on my left, son was on the right. When those engines ignited, the color on their face, everything around us was about the color of that orange tank. We were about 10 miles away, and I could read a newspaper from the light from the shuttle launch. We didn't hear anything initially because we were so far away, but then there was a low-level rumble, and it's pretty soon a popping and cracking. Eventually, you almost wanted to cover your ears. It was so loud. And then 2 minutes later, off on the distance, we saw this little white dot, and that was this space shuttle on its way into orbit. That was one of the most beautiful launches I have ever seen. It was about 6:22 in the morning, and there were broken clouds in the sky. And as the shuttle passed through those clouds and up into the sunlight, the contrail coming off the back of the shuttle was red, white, and blue. It was an incredible sight and incredible sound. If you ever get down to Kennedy Space Center or over to Wallops even in Virginia, go to a launch. It's just incredible to be there. This is an engine firing. This plume goes away almost instantly, and then the engine keeps firing. But the important thing I want to show you in this picture is there's a very thin blue line across here. That's Earth's atmosphere. If you go home and take an onion out, and you think about shrinking Earth down to the size of that onion, and you peel off that outer skin, you just removed Earth's atmosphere. There's not a lot of air between you there in East Brunswick and the top of our atmosphere. Matter of fact, it's about 60 miles to the top of our atmosphere, so not a lot of air above us. So we've got to take pretty good care of what we've got. John Grunsfeld, he's going out to work on Hubble. He's in the spacesuit. John's been here in my museum at home several years ago. So I love this picture because I'm going to ask you some questions. Raise your hand if you think, as you think about this. In that picture, how many of you think up is this direction in that picture? Raise your hand if you think up is this way. I'm not seeing any. If you think up is this direction in that picture, raise your hand. Okay, you. How about if up is right toward, I'm pointing right towards you, how many of you think up is that direction in that picture?
Yes.
The thing is, there is no up or down in space.
Oh,
If we all had that library room in space, some of you be on the ceiling, some of you be on the wall, some of you be on the floor. I often tell teachers when I go into their classroom that isn't that the way your classroom is? The kids are all over, bouncing all over the place. But there is no up or down in space. And to prove it, there's Martha. I wish I had that much hair, but her hair is going all directions because there is no up or down. So when somebody tells you one direction up or down in space, there is no up or down. The shuttle, when it was flying, would land like an airplane on a runway. But if something were wrong, it couldn't fire up some engines and go around and try coming back again. It had to land first time every time. So there are 2 tires here, 2 tires there. Those weigh about 200 pounds apiece. and you can't see them very well. If I step out of the way, back off behind me, there are two tires, a rear shuttle tire, like one of these, and a front one. So they weigh about, the rear one weighs about 200 pounds, almost as much as I do. So getting into the back of my truck to take it anywhere is a little bit iffy sometimes. That's the space station. It will fly over East Brunswick every now and then. If you see a bright dot, the brightest thing in the sky, other than the sun or the moon, and it's moving real fast, no flashing lights, it's probably the space station if it's coming out of the west to the east. And it's about the size of a football field, including the end zones. You students there in the room, some of you may be thinking about what you want to do when you get a job as an adult. Some of you may want to be artists, some of you may want to be teachers, some of you may want to be doctors, some of you may want to be attorneys or drive truck. Whatever it is, you can do it if you want. It's yours for the taking, but you've got to want it enough. And I challenge all the adults there in the room. I challenge you to mentor these kids, talk with these kids, teach these kids, because just the right word from you might spark something in them to someday that child might take what you said and be the next person to walk on Mars, or might be the next Neil Armstrong, or the next Sally Ride, or that person might be a future president, or develop a cure for cancer. So I challenge each of you adults, if you have any kind of contact with kids at all, mentor them and talk with them. Because for me, it's exciting to walk into a classroom and look around and say, that child could be a president someday, or that person could be a person to walk on Mars. That's exciting and energizes me. That picture is Anne McLean. Anne McLean, when she was 3 years old, she told her mom, I want to be an astronaut. She went off to elementary school here in Spokane, middle school, high school. She graduated, went to West Point, became a helicopter pilot. And Anne McLean, this is a picture of Anne McLean on board the International Space Station. I talked to her mom a few months ago, and her mom said she's probably training now for her next trip up to the space station. Remember, I was talking about us flying to the moon and landing people on the moon in the next few years? This rocket right here is going to be taking our astronauts to the moon. That's the SLS, part of the Artemis program. And I'm hoping that Anne McLean will be the first woman to step foot on the moon in a few years. So, students there, if you want to do something like that, you can do it. Anne wanted to do it since she was 3 years old, and is living it out now. I'm going to just spin through. I want to give you lots of time for questions. How are we doing on time, Isaac?
We're going to be able to see anything outside? It's your call.
We're doing good. I think it's actually cloudy outside.
Again.
Does anyone look outside right before you came?
Oh, you can go look, but you can ask a question. Does anyone have a question?
Did you have a couple more minutes, or did you want to do questions now, Joe?
I've got all kinds of time. Like I said, my wife is at a wedding tonight, so I've got all kinds of time.
Free night.
This was a picture that I took a year ago last April. I was down at Pasadena at the NASA Jet Propulsion Lab, and this is the Europa Clipper. The Europa Clipper is at Kennedy Space Center right now and getting prepared. Hopefully in October, we're going to launch it toward Jupiter. And I think it's around 2030, it's going to go into orbit around Jupiter. And it's going to look for signs of life on one of Jupiter's moons, Europa. That's why it's called the Europa Clipper. But Europa, the moon Europa, has an icy crust and then probably a liquid ocean underneath it. And so where there's liquid water, there's a possibility of life. Europa actually has more water on it than Earth does. Now, if there is life on Europa, it's not going to look like you or me. Who knows what it could be? It could be tiny microscopic life, it could be fish-looking life, but we think that that's a good place to be looking in our solar system for place that life might exist. So over the next few years, watch for the Europa Clipper as it goes into orbit around Jupiter and starts looking for possible signs of life there. I've got to throw in a picture once in a while of an eclipse. This was, I don't know how you folks all did with the eclipse back in April. I ended up driving a 4,000-mile round trip to Indiana to watch the eclipse. And this was a picture that I took of the eclipse on April 8th. So hopefully you guys got a good shot of that too. Did anybody there get a chance to see the Northern Lights May 10th? Was it pretty good display there in East Brunswick?
Yes.
Was it? This was from my house in Spokane. I have never seen a display like that. So for me, it was just really cool to see just overhead everything glowing in colors and light. So hopefully you guys got a good chance to see it too.
Yeah, it was
No.
okay. Yes.
Cloudy.
Oh, cloudy? Yeah, we had a great night that evening. So it was a wonderful opportunity. So I just, I want to kind of finish up this portion of the program with, folks, you only climb as high as you reach. So reach for the stars because you can do it. So with that, there's some great resources from NASA out there. If you go to just type in NASA and educational resources, there's going to be all kinds of things that pop up. And as always, I blank out on one of the ones I use all the time. But NASA's Eyes is a great interactive site to go to. Just type in NASA Eyes, and you can look at our solar system from all different planes and look at it in real time, where the planets are and where everything is. Let's see. Space Place. That's the one I always forget. Parents, Space Place is an awesome resource. If you've got a science fair project you need, or you want to make space cookies, it's a NASA site, so it's safe. So go to spaceplace.nasa.gov, and it's just you're gonna find all kinds of rabbit trails that you can use, and it'll take you to. So I highly recommend Space Place because I use it a lot in the work that I do with students. So with that, I'm going to just open it up to you and any questions that you all might have.
Does anyone have any questions?
I have a question.
Yeah, if you say it loud enough, it'll pick up.
How is it decided when and how to invest in space programs?
How is it decided to invest in programs?
Yeah, is it at the federal level? Like who makes for the budget?
NASA has, at each of the centers, NASA has folks that, and scientists that come to them. There was one picture I didn't stop at, but there was a proposal that was brought to NASA. The person wanted to build a telescope that will categorize and map all the objects, dark objects, asteroids in our solar system that are football-sized field or size or larger, and categorize them and track them, and then follow them so that we can see in advance, years out, where they are and if they're going to come toward Earth. And if that be the case, we might have a way of deflecting just a tiny bit to deflect them away from Earth. I know this is a long way around to your question, but they came up, this group of scientists came up with this idea and a telescope. They submitted their proposal and it was accepted. And I worked with Dr. Amy Manzer at the open house at JPL a year ago, April, and she talked with what they're doing in this project. So it's a lot of scientists that come up with great ideas. Tom Timko, I think he's on with us tonight. He's another solar system ambassador. He has a contact with one of the scientists that came up with the idea of building the little vehicle, New Horizons, that flew out to Pluto. And he came up with the idea and helped develop it, and he led that through NASA and lots of hard choices back and forth and a lot of hard discussions, and they were able to get that proposed and passed and flown and budgeted. And so it's just folks coming up with great ideas and approaching NASA with it, and then getting approved, and then the building process. So it's a lot of smarter people than me.
I feel like we haven't heard about it in a little bit, but what's your take on some of those commercial flights that are kind of going up to space real quick and then coming back down, like Jeff Bezos and Elon Musk and stuff? I mean, do you think that we'll continue to see that market grow and that there will be more opportunities for cheap space travel or affordable space travel? And if so, how far away are we from that point in time?
I'm a big proponent of anybody that is wanting to build or come up with a way of getting into space. Richard Branson of Virgin Galactic, and Bezos and Musk, and there's others. There's some folks in Colorado that are working on a space plane. So there's a lot of folks that are doing it, and I'm a big supporter of them, because the more they do, the more chances we have of getting into space. I've always, when my kids were younger, they're in their 40s, well, my son's 40 and 38 for our daughter. I told them when they were kids, they probably were going to get the chance to vacation in space. Well, maybe, but there are companies out there right now that have plans in the not too distant future, within the next 5 to 10 years, of launching hotels into space where people can go and spend vacation time. You and I probably aren't going to be able to afford it. At least I know I can't. But when I was growing up, and up until just a few years ago, to give you an idea, it was $10,000 a pound to fly me into space. That's expensive. Now, with like Elon Musk and his launch vehicles, they don't have to rebuild the booster every time. They fly it, bring it back, refurbish it, get it ready, and within a short period of time, launch again. And so those launch costs are dramatically lowering than what they were. So I think anybody that's doing stuff like that, I'm all for it. To me, it's exciting. The Elon Musk launches, I won't catch every one of them, but I'll tell you what, I sure watch a lot of them, and those landings are spectacular. I was at his Super Heavy launch back in 2018, the inaugural launch. I was about 3 miles away at the Vehicle Assembly Building. And let me tell you, that's just incredible to see. But I think in your lifetime, in your kids' lifetime, you're going to see so many changes and new technology. And we've got to look at different ways of powering our vehicles. Chemical rockets, that's expensive and it's heavy. There's a probe headed on its way out into the asteroid belt near Jupiter, and it's called Psyche. And it was launched on board a chemical rocket. But once it got into space, it used essentially an ion engine. And if you were to take your hand and put a piece of paper on it, that's the amount of thrust that little rocket engine is producing. But in space, with no atmosphere and the lack of gravity, it can build up some pretty just incredible speeds to get out to a rocky world called Psyche that we think is a planetesimal. It used to be probably the core to a small planet or something, and the outside was stripped away and left just the core. And so that is going to help us understand our planet's core better. But I think new technology like that, there's a fella here in Spokane that's working on a new type of engine. I've seen recently some concepts where it would get us to Mars in 2 months. Right now, we're looking at 7 to 8 months to get to Mars with our typical chemical rockets. But this would get us to Mars in about 2 months. And so those kinds of things are just incredible what they're doing. And again, in our lifetime, my so I get a little excited about things like this. My grandmother, she lived to be 100 years old. My grandmother saw horse and buggies. She saw the first cars. She saw trains. She saw the first planes. Then she saw people walking on the moon in just her 100-year lifetime. Imagine what we are going to get a chance to see in our lifetime. Some pretty cool things are coming along. Hopefully that answered your question.
Yeah, thank you.
Previously in your discussion, you mentioned Europa having water on it that could potentially have life. But that's just only one of the many moons on Jupiter. Could it be possible that the other moons could have an equal amount of water, or even more so, which could also contain life? And if that's the case, those moons be studied, just as well as Europa.
Oh my goodness. Europa is only one place in our solar system that we think has abundant water. There are other, as you say, there are other moons around Jupiter that possibly could have water. There's moons around Saturn, we know, Enceladus being one of them, that has liquid water under an icy core. So yes, absolutely. There are other places in our solar system where life could exist. Europa just happens to be one of the top candidates, Enceladus being another. But there's other places, but it's expensive and we can't send probes out to all of them. But Europa, what we'd like to do eventually is we'd like to send a lander down and they're working on a method of using heat to core down or drill through that ice crust and get into the liquid water underneath that probably exists underneath and sample that and see if there are markers for life there. So yeah, you're exactly right. Yep.
Do you have a question?
Yeah, your discussion about Skylab was interesting, and I wish that I had paid more attention to Skylab when it was up there, when it was at a different time of life for me. However, my son and I were fortunate enough to be visiting Kennedy Space Center when they were assembling the parts for the current ISS. So we've been following it ever since then. And we never fail to go outside when our app on our phone tells us that it's coming over. It never gets old. The question I have is, in the news lately, is speaking of now the planning for bringing down the ISS because it's reaching its end of life. What would it take for NASA to be convinced to somehow find an alternative to maybe put it in a higher orbit or do something with it, rather than just bring this thing down into the ocean? It seems a shame.
There's a lot of discussions going on about that right now as you're speaking. And one of the things I just saw this week, within the last 2 days, is NASA's kind of changing a little bit on their thoughts, where they might be open to bringing back some of the components to put in museums of ISS. The one thing that we've got to remember about it is, like, I'm driving a 2006 Mustang. My 2000 Mustang right now is in really good shape. But 50 years from now, my 2006 Mustang, it's some wear and tear. Hoses aren't going to be real good. The body may not be real good. And we saw this with the Mir space station as well, that over time, where they're orbiting, the space station, ISS, is at 250 miles up. There is still some weathering, and I use that term loosely, some weathering taking place on the station where there is some atomic oxygen. It's here in your room, you're breathing O2, but at that altitude, it's just oxygen. And so as it passes through, there's some friction. And if you look at some of the spacewalks, you'll notice around the hatch on the airlock, there's some discoloration that's happening. And so over time, I mean, I'm getting older. I'm 68 years old. My body doesn't function like it did when I was 25 years old. Right now, I'm suffering from sciatica. Same thing applies for a space station. Personally, and I shouldn't do this, but personally myself, the space station, if we're put it into a higher orbit for people to come to, over time, I'd really be concerned about going to it, just simply because some of the solar panels they've been hit by debris in space, and the vehicle getting hit with debris, and just the wear and tear on it. So I think their idea of maybe bringing some back from ISS and put in museums is great. But I think over time, it's like our cars and like us. We just, things start failing on us.
Thank you.
I feel like in the future, we'll see a part of the ISS in your museum.
I certainly hope so.
Collector piece there.
Any other questions? Yes.
Yeah, something that I'm always curious about is like dark energy, dark matter. It seems like for quite some time we haven't been able to like quite understand it well. Are we getting closer to understanding it? And can you explain exactly what they are?
You know, I'm not that much of an astronomer to really know that. I know that there is something out there that we can't see in our universe that is causing the universe to expand, and we think that's dark matter and dark energy. I think we're going to learn more about that through time, but I'm not an expert on that. My area is in general science, and so I'm sorry, I don't have a really good answer for you on that one.
Of course, thank you.
Other questions? No, if there are no questions, we do thank you so very much for sharing your collection. It is very, very impressive. I have to say, just looking at all the artifacts that you have there, I'm pretty quite jealous.
Well, I've had fun. I started this collection back in about 1974, 75, when I met my first astronaut, Jim Irwin. He was from Apollo 15. And my sister and I went and met him. He signed a book for me, and that kind of started it. And then I went off to school, met my wife, we got married, and my wife is a very wonderful person. She lets me go out and indulge myself a little bit. And so over the years, I've gone out and gone to auctions around the country and eBay and picked up some of these things. But for me, as a teacher, these items are so much fun for me to be able to share with people, to be able to share with you and students, and just like I said earlier, maybe spark something. When I was growing up, I lived in a very small town in central Washington. There were 37 of us in my graduating class, and I didn't get a chance to see things like this. I remember one time my parents drove me to a nearby town of about 40,000 people, and at the mall there was a huge rocket laying on site. And that just wowed me. And so my thought is, if I can go into a classroom and show a child, I've got a piece of Mars here, a Martian meteorite. If I can show a child that and they can touch it, who knows what that spark might set with them and where they might go from there. So to me, that's really important to be able to do with these items, is share.
And that's fantastic. And Joe, thank you so much for your time.
Good luck with the clouds.
Yes, one question actually.
Is that an official like uniform, like I see you have like?
The one I'm wearing, I ordered this from the folks that supply them to NASA. I gave them the specs that I wanted to make it like the astronauts. So this is what you would see the astronauts wearing when they go to events such as this or to schools. And it's made of the fabric, the Nomex fabric. The patches that you see on it are actually my mission patches. These two right here are the patches from when my work flew on the International Space Station. And then my name tag, that patch actually went and spent almost a year on board the International Space Station. And most of that time was out by the alpha magnetic spectrometer out on the main truss of the space station. And so that's been in space for almost a year. And then when the Teacher in Space program was up and running, I hadn't been teaching long enough, so I wasn't accepted. But I did apply for the Teacher in Space program, and I have one of those patches. I'm not wearing it right now, I guess. And then the solar system ambassador patch is always so important to me because these folks have a desire to share with you all. And so, like I said, there's 1,300 of us, and Tom Timko and I go out and have fun. Tom does an awesome program, and he and I met a few years ago back at JPL and worked together and just had an awesome time. And we maintain a connection over the years. So I'm glad to see Tom was able to make it with us tonight.
Thank you.
Awesome. Well, thank you so much again.
Thank you.